Hello students, now we are going to discuss about construction and working principle of IMPATT Diode. IMPATT Diode stands for Impact Ionization Avalanche Transit Time Device. It mainly works on the principle of impact ionization and avalanche multiplication of charge carriers. IMPATT diode can be fabricated using gallium, silicon, gallium arsenide or indium phosphate. Gallium arsenide material has several advantages like high efficiency, higher operating frequency and low noise figure, but it has disadvantages like fabrication complexity and more cost. It can be fabricated as single drift device or double drift device. In single drift device, only one type of charge carrier can drift through the depletion region. When you consider P plus N plus device means when it is reverse biased, the electrons from P plus region can drift through the depletion region and it can reach the N plus region. Hence, it is called a single drift device. In double drift device, both the charge carriers can drift through the depletion region. Hence, it is called as double drift device. Figure A shows the double drift impact diode made up of silicon material. Figure B shows the field distribution and figure C shows the doping profile. When we consider figure A, there are four regions are there. One is N plus region, which is heavily doped N type material, and the second one is P moderately doped P region. Third one is intrinsic semiconductor or pure form of semiconductor, and the fourth region is P plus region. It is heavily doped P type material. When we come to figure 2, there is a huge potential difference exists in the junction 1 because there is a sudden change in the type of semiconductor type of charge carriers from N plus region to P region. Similarly, when we consider junction 2, there is a slight change in the potential because of there is a change from P-type material to intrinsic form of semiconductor material. In the third junction, again there is a sudden change in the type of conducting material from I region to P plus region. IMPATT diode is operated in reverse bias mode. This bias voltage is a combination of RF voltage is superimposed on the high DC voltage. Whenever the applied external voltage exceeds the breakdown voltage, the electrons will gain the enough energy from the applied voltage and they will knock off the electrons in the valence band to the conduction band. As a result, a new electron-hole pairs are generated. These newly generated electron-hole pairs are called as secondary electron-hole pair. Due to the sufficient number of secondary electron-hole pairs, the exponential increase in the current continues until the sine wave reaches the zero. Then it drops exponentially. Due to this, avalanche breakdown will occur and an enormous amount of current flow through the diode. IMPATT diode operates in reverse bias mode and exhibits a negative resistance. The phase difference between externally applied voltage and internally generated current is 180 degree. The main reason for this phase delay is 90-degree phase delay is due to avalanche effect and remaining 90-degree phase delay is due to transit time effect. At low frequencies, their power output is inversely proportional to frequency, and at high frequency, power output is inversely proportional to square of the frequency. They are oftenly used in the design of oscillators and amplifiers where the high output power is required. These diodes are low cost, more reliable, and compact in size. These diodes are noisier than the GAN diode, therefore they are rarely used in local oscillator and in receiver applications. Now we will see the performance parameters of IMPATT diode. Theoretically, it can able to produce 30% of efficiency. However, only 50% of efficiency is possible when we use silicon semiconductor material, and 23% of efficiency is possible whenever we use gallium arsenide material. It can able to produce microwave signals of having frequency from 1 GHz to 300 GHz, and maximum output power as a single diode. It can able to produce 5 watts in X band and 6.5 watts at 30 GHz. And when the several diodes are combined together, it can able to produce 40 watts in X band, and it can able to produce 4 kilowatts of pulsed power outputs.